Hi friends, this is Masuk. Here I come with another video to help you to do the antenna array design with the help of MATLAB software, and you can make different array antennas with the help of this software like we did previous with the antenna designer. First, go to application. You can find the antenna array designer before we work with the antenna designer, so this time we have to work with the antenna array designer. Click on it. It will take you to the new tab. If you enlarge it, there will be an option for new. Click new, or if you already previously done, click open. And after clicking new, you will get different options. First, you have get the array, that what kind of array you can use. There is linear, rectangular, circular, whatever you want. There you can find the antenna, what you have used in the previous, you can use it. Or if you don't find something like this, you cannot have it here, you can use another antenna. Also here you can use the backing, you can use or you cannot use, but it's better to use the backing. So let's choose the linear one. I choose the linear with the elements. Here you can use 2, 4, 6 elements. The minimum requirement was the 2 elements for the linear. And let's choose the microstrip antenna. And after that I get the backing rectangular. And finally let's put the frequency. So I put the 2.4 gigahertz as our teacher recommend. Click accept. If you click accept, uh, it will take you to the designer software, and where you can get the 3D pattern, azimuth, elevation, and so on. For before working on it, I already did it because it takes much time in impedance and correlation, so I already did it. So let me cancel this one and let's go for this one that I already did. So here you can see that you will get the properties, how many elements, the spacing, elements spacing, and so on. First you will click on 3D pattern, and this is the 3D pattern you will get. Remember this, we need these values to compare between the three frequencies, the output frequencies, the maximum and the minimal value, that is called also the notch. Then you get the azimuth, the elevation, the impedance, and the correlation. The correlations you can get if you have more than two elements there. So in the correlation you can only get between the two elements. So here we already have two elements, so we just click in one element and two elements and click OK, and it will be the same value that already we have here, so you can see. So and after that the S parameter that we get till now from this software. Here you can export as a workspace, that will take you to the workspace, and as a script if you want, you can save it as a mat file. So till now we have to do this, and after that I will show you that how do you gonna do the azimuth and the elevation, the minus 3 dB beam width and the half power elevation, half power value. So let's go to the report that I write already. So you can change that this is my antenna or array I use, the linear array, and even you can see the banking, and so I use three different frequency. One is 2.4 and 5.8 and 9.5 gigahertz. That's all, and you can use it as well because the teacher recommend this for us. And this is the introduction part. I used my antenna before. I use with 4 elements, so it has 4, but you can use with 2. And how I take the screenshot of it, you can see it here. So for that, just go it here. You can just click like this, and just you can design as you want. Okay, I don't want to show you now. And so this is the 3D pattern. Oh, okay, so let's go down here. You can compare the frequencies. different frequencies, but in the antenna designer we compare the comparison between easy, because there was only one reflector, but you will get here the two reflector. Okay, so let me show you how you get the two reflector here. One is the linear array element reflector, and another is one the reflector exciter patch Microstrip. Okay, so these are the values that you have to compare, and don't compare that already have the same value. So just take one, and that's enough. And after that, after that we're gonna optimize the 3D pattern, the bandwidth Microstrip array patch antenna. Is a bit long, sorry for that, but that we have the task. So I already mentioned you need these values to compare. So with the three different frequency you can compare and make some comments on it. Okay, here you get the maximum value and the minimum value, that is also called notch. Okay, so till that you have to work with this uh, with this antenna designer. Now how we're gonna check the azimuth and the elevation, and how we have to do the half that this half power beam width and the minus 3 dB beam width. You can see the table very clearly that it's how we get the minus 3 dB from the peak. We just make a minus 3 and we get the minus 3 dB value of it, and half power beam width, how we gonna get it, I'm showing you now. So the peak is already arrived here, you just have to add minus 3 on it. Okay, and here is how we're gonna get the half power beam width. Click antenna matrix, very simple, it will show you directly. Click remove and wait a few minutes. That's all. So here you get the del theta, and the half power beam width is 20 degree, and these are the values that we have to compare, and I already did it here. I compare them and I make a short note what I get from here. Okay, it's the same thing for elevation as well. Go there, and already peaks is here, minus 3 dB, just add minus 3, and antenna matrix, click remove, and you will get also the same half power beam width that you have to compare between them. Okay, this is the comparison results I got, and there is a short note. After that, finally you get a conclusion part, that in this paper what you get, how you get it, and so on so on. In the reference it's better to use where you get it, from which year, which books. Is very simple. So till now we're gonna do this, and this is easy task for you guys, I believe. And you so every time take screenshots and follow the paper that already uploaded in the e-learning, and here you can use the new for the different frequency that I already did in the previous antenna design. Okay, so this is for today. Hope you like it, and if you need something, just knock me. I will try my best to help you. Thank you so much.